A very good morning, dear children. Today we will continue with chapter 14, Measurement and Effects of Heat. And today specifically we will be learning about numericals. Okay, so let's begin with numericals. First numerical, how much will be the temperature of 68 degree Fahrenheit be in Celsius and Kelvin? Now here what they have done is they have told that the temperature is 68 degree Fahrenheit. How much will that same temperature be in Celsius and Kelvin? Okay, so let's begin by writing what is given. What do we have? We have the temperature given in Fahrenheit. So we write F for Fahrenheit. F is equal to 68. That's the only thing that's been given to us. To find, what are we supposed to find? We are supposed to find the temperature in Celsius. That is why C is equal to question mark. And we are supposed to find the temperature in Kelvin. So K is equal to question mark. So here the formula which we will be using will be F minus 32 divided by 9 is equal to C upon 5. Okay. So this is a formula and we are going to be substituting the given value. There's only one value given to us and that is Fahrenheit. Okay. So F we will be substituting. So we know F is 68. So 68 minus 32 by 9 is equal to C upon 5. Only thing we have done is we have substituted the value of F. Okay. Now we are going to do the subtraction first. That is 68 minus 32. That is 36 divided by 9 is equal to C upon 5. Now we know 36 comes in the table of 9. So we can divide 36 by 9. So 9 fours are 36. So we write 4 is equal to C upon 5. Now what do? We cross multiply. Okay, so we know 5 fours are 20. So 20 is nothing but the temperature in Celsius. Okay, so we have got the first part of the answer, that is C we have got is equal to 20. Now what are we supposed to do? We are supposed to find out the temperature in Kelvin. Alright, so what is the formula? The formula is K is equal to C plus 273.15. That means whatever temperature you have got in Celsius, you have to add 273.15 to that number and that will be the temperature in Kelvin. So we are going to substitute the value. Now here which value are you substituting? The value that you have got in Celsius. So you know for in Celsius we got it to be 20. So 20 plus 273.15, that is 293.15. This will be the answer of temperature in Kelvin. So you end up the entire numerical by writing a final statement, that is the temperature in Celsius is 20 degrees Celsius and in Kelvin is 293.15 K. Okay, I hope this is clear. Coming to the next numerical. What must be the temperature in Fahrenheit so that it will be twice its value in Celsius? Okay, understand the numerical first. They are asking you what will be the temperature in Fahrenheit. That means F you have to find out. Which temperature are they talking about? That temperature when the Fahrenheit is double that of Celsius or twice its value in Celsius. So let's write what is given. Given is Fahrenheit is twice that of Celsius. That is F you will take it to be 2 times Celsius or 2 times C. That is when it says twice its value in Celsius. So Fahrenheit is 2 times the value of Celsius. That is what is given. Okay. What are you supposed to find? You are supposed to find the Fahrenheit temperature. Okay. You will understand this when we are solving it. You will understand what we are trying to tell. So the formula is same thing, F minus 32 divided by 9 is equal to C upon 5. So here the condition they have given is Fahrenheit is twice that of Celsius. So find out what is Fahrenheit. Alright, so we are going to use this formula and we'll just see how this comes out to be. So that's the formula we are using. Carrying that over, the only thing you're going to do is you're going to substitute the values in the formula. Now there is no value given as such. The only thing we are considering is we are going to substitute, instead of F, we will write it to be 2C. That is because they have told Fahrenheit is twice the value of Celsius. So wherever F is written, instead of writing F, you will write 2C. Okay, so let's substitute it. So you have 2C minus 32 divided by 9 is equal to C upon 5. Now how are you going to solve this? You will cross multiply. So 5 will go in the numerator on the left hand side and 9 will go into the numerator on the right hand side. So 5 into 2C minus 32 is equal to 9 into C. So here we have multiplication. So we will multiply. So 5 2s are 10. So 10C minus 5 into 32, that is 160, is equal to 9 into C, 9C. Okay, now what is the next step? This 9C which you have, you take it onto the left hand side, and that 160 will come on the right hand side. So the number which has the variable comes onto the left and the number without the variable goes to the right. So 10C minus 9C is equal to 160. Okay, 10C minus 9C is nothing but C. So C we have got is 160. Okay, so this is what we have got. We have got the temperature in Celsius. Were we supposed to find the temperature in Celsius? No. We were supposed to find the temperature in Fahrenheit. To find is F is equal to question mark. But what do we know? We know that F is 2 times C. Now here we already know the value of C. So you can find Fahrenheit. So we will write F is equal to 2C. This is what we know. From this C we have found out. We only have to substitute the value. So here you will substitute 2 into 160. Okay, so you come to know that the temperature in Fahrenheit, where it is twice that of Celsius, is 320 degree. Understood? Okay. Now going to the next numerical. At what temperature will its value be same in Celsius and in Fahrenheit? What is the question asking? The question is asking that there is one particular temperature in which Celsius as well as Fahrenheit both show the same value. Which is that temperature? That is what they are asking. Okay, I repeat, at which temperature will the value of Celsius and Fahrenheit be the same? That is what we have to find out. Okay, now we will write first what is given. What is given? The only thing that is given is Fahrenheit and Celsius is equal. That is what they are telling. The value is the same. So for given, you can take this as F is equal to C. The value is the same. So you will consider it as F is equal to C. What is the formula you're going to be using? You're going to use a formula, the same thing again. F minus 32 divided by 9 is equal to C upon 5. Okay. So this we will take forward. That is the formula. We are going to substitute the values. Now here what did we do? F, we have taken it to be equal to C. That is why instead of writing F, you're going to write it as C, because it's told that the values are the same. Okay, so instead of writing F, what are we writing? We are writing it to be C. So we substituted it and we've got C minus 32 divided by 9 is equal to C upon 5. Same procedure it is. The only thing here is instead of 2C, in the previous numerical we saw that it is 2C. Here the only thing is that it is C. Now what are we going to do? We are going to cross multiply. When you cross multiply, 5 goes on to the numerator on the left and 9 goes to the numerator on the right. So this becomes 5 into C minus 32 is equal to 9 into C. Again here you have multiplication, so you multiply, that is 5C minus 160 is equal to 9C. Again 9C will be brought onto the left hand side. Now 9 is in plus, or it is in the positive form. So when you take it onto the next side or on the other side, it will become 5C minus 9C is equal to. Now you have minus 60, you are taking it on the right hand side. So minus 160 will become 160. The minus sign will become opposite. Okay. So 5C minus 9C is minus 4C. So minus 4C is equal to 160. So what is C then? C will be equal to 160 by 4. Okay, the 4 that is there, that has moved into the denominator. Okay, now if you go to divide it, you understand that the value is minus C is equal to 40. Now it is minus C is equal to 40. So what will C be? C will become minus 40. Okay, so what have you got? You have got that the temperature in Celsius. When you say that the temperature is minus 40 degrees Celsius, you will say that Fahrenheit is also that much. That was the question. Which is a temperature where Celsius also and Fahrenheit also is the same? So it is when you have minus 40, Celsius also is minus 40, Fahrenheit is also minus 40. Okay. Now going to the next question. A bridge is made from 2-meter long iron rod at temperature 18 degrees Celsius. The distance between the two rods is 0.4 centimeter. Up to what temperature will the bridge be in good shape? So they have first given me the bridge length, that is 20 meter, and they are telling that at 18 degrees Celsius the distance is 0.4 centimeter. What will be the temperature till when the bridge will be in good shape? Okay, so 20-meter long iron rod, that is what is being given to us. So let's write what is given. Given is length of the iron rod is 20 meter. Okay, now what are you going to do? You're going to convert this meter into centimeter. Okay, now we know 1 meter is 100 centimeter. So 20 meter will be 20 into 100, that is 2000 centimeter, and this is at 18 degree Celsius. Okay, now what is the next thing? The distance between two rod is 0.4 centimeter. Okay, so that also is given. What is that? Distance between the length of two rod is 0.4 centimeter. That is what we have written. Now here there will be no conversion done. Why? Because it's already in centimeter, so no need of any conversion to be done. Okay, now what is it that you're supposed to find? Up to what temperature will the bridge be in good shape? Means that you're supposed to find out the final temperature. Now, one thing that we know is temperature coefficient of linear expansion of iron. Now here, why are we considering iron? That's because we are talking about a bridge that is made up of iron rod. That is why we are interested in finding out the alpha value or the temperature coefficient, linear expansion, because it's a rod. So we are talking about alpha, and that is why we need that value. The value is 11.5 into 10 raised to minus 6 degrees Celsius. This is the alpha value. Okay. Now we are going to write the formula. Formula is delta L divided by L is equal to alpha delta T. Now this is what we have done in the previous class. We learnt about how we have got this. Okay. So this is a formula that we are going to be using. What are we going to do? We are going to only substitute the given value. Okay. So when you say delta L is nothing but the change in the length, and that change in the length is nothing but the distance between the length of the two rod. So when I say that the distance between the length of the two rod is 0.4 centimeter, I'm basically talking about the difference in the length or the change in the length. Okay, so this is going to be 0.4 is delta L. So we will write 0.4 divided by, what is the length that we have got in centimeter? It is 2000. So that comes in the denominator. Okay, is equal to, I told you alpha value already, that is 11.5 into 10 raised to minus 6 into delta T. Now delta T we know is nothing but the final temperature minus the initial temperature. Okay, now we know that the initial temperature is given, that is 18 degrees Celsius. We are supposed to find the final temperature. That is why we will write T minus 18, where T is the unknown value. Okay, now what do you do? This 11.5 into 10 raised to minus 6 will be taken into the denominator along with 2000, so that whatever is unknown, that T minus 18 that is unknown to us, that remains on the right, and the remaining is taken onto the left hand side. So this is what we have till now. 11.5 into 10 raised to minus 6 has to be taken on the left hand side so that it gets separated from what is unknown. So let's take it onto the left. So now we have 0.4 divided by 2000 into 11.5 into 10 raised to minus 6 is equal to T minus 18. Now let this T minus 18 be as it is on the right. Okay, we will try solving and simplifying the left hand side, and then we will take the unknown. So we have 0.4 divided by 2000 into 11.5 into 10 raised to 6. So first let us multiply this number, that is 2000 into 11.5. When we multiply, we get 0.4 divided by 23,000 into 10 raised to minus 6. Okay, now this 10 raised to minus 6, if you take it into the numerator, the minus 6 will become plus 6. Okay, so this will be 0.4 into 10 raised to 6 divided by 23,000. Okay, now when I say 10 raised to 6, it means that I have a number which has 6 zeros in it. What do I do? In the denominator, 23,000 has 3 zeros, and in the numerator I have a number which has 6 zeros. So I will cancel the zeros. Okay, so what do I get? I get 0.4 into 10 raised to 3 divided by 23. I hope you have understood this. The 3 zeros of 23,000 has got cancelled with the 3 zeros of 10 raised to 6. From 10 raised to 6, if I remove 3 zeros, if I cut the 3 zeros, I will have 10 raised to 3 remaining. Okay, now what do I do? 0.4 into 10 raised to 3. When I say 10 raised to 3, that is nothing but it is 1000, because we know 1000 has 3 zeros in it. So 10 raised to 3 means what? It is 1000. So here I am telling 0.4 into 1000 is my numerator. What is 0.4 into 1000? It is 400. Why 400? Why not 4000? Because it's in a decimal. It is 0.4. Okay, because it is 0.4, 10 will be cut. So 0.4 into 1000 is 400. 400 divided by 23 is equal to t minus 18. If you go to do 400 divided by 23, you get 17.3. Okay, so 17.3 is equal to t minus 18. This is what we have till now. So this is what we have. Now what do we do? That 18 which is there from the right hand side will move on to the left hand side. Now it is minus 18. So minus 18, when it changes its side, it becomes plus. So I have 17.3 plus 18 is equal to t. How much is 17.3 plus 18? It is 35.3. And this will be the final temperature. Okay, I hope this is clear. Coming on to the next one. At 15 degrees Celsius, the height of the Eiffel Tower is 324 meter. If it is made up of iron, what will be the increase in length in centimeter at 30 degrees Celsius? They have given you two temperatures here, 15 degrees Celsius, 30 degrees Celsius. They are telling you at 15 degrees Celsius the height of the Eiffel Tower is so and so. Now they are telling if you increase the temperature from 15 to 30, what will be the increase in the length? Okay, so first thing that is given is height of the Eiffel Tower is 324 meter. So we will write given height of the Eiffel Tower is 324 meter. Now here it is meter again. I told you 1 meter is 100 centimeter. So 324 meter will be 324 into 100. That is 32,400 centimeter. Now this is at a specific temperature, that is 15 degree Celsius. Temperature change. It is very, very important. Whenever you have a numerical where there are two temperatures given, okay, instead of writing the two temperatures in the formula and then subtracting it, you directly subtract it and find out what will be the temperature change. So here I have the initial temperature as being 15 and the final temperature as 30. So I will do final temperature minus initial temperature, that is 30 minus 15, which is 15 degrees Celsius. Okay, so 15 degrees Celsius is my temperature change. What will be the increase in the length in centimeter? So to find increase in length in centimeter, okay. Now again here they are specifying it is made up of iron. So obviously my alpha will be, it will be iron, the same thing that you used in the previous numerical. So it's going to be 11.5 into 10 raised to minus 6 degree Celsius. What is the formula we are using? Formula we are using is delta L upon L is equal to alpha delta T. Now here you will understand delta T. In the previous numerical, we did T minus 18. That is because we did not know what was the final temperature. Whenever you know the final and the initial temperature, instead of writing TF minus TI and then doing the subtraction in the formula, it is better that you do it first and you find out what is the difference. So here where you have delta T, you can directly write 15 instead of writing 30 minus 15. I hope this is clear. Okay, so substituting the given value. Delta L is what we have to find, that is increase in the length is what they have asked, that is delta L, change in the length or the increase in the length, that is what they are asking. So here delta L is going to be question mark. So we will write it as it is delta L divided by length they are asked, we have converted it already, so it's going to be 32,400, okay, is equal to alpha delta t, that is 11.5 into 10 raised to minus 6 into 15. Okay, so so this is what I have got. Okay, now what do I do is 32,400 goes into, it cross multiplies and goes into the numerator. Alright, so I'm going to get delta L is equal to 11.5 into 10 raised to 6 into 15 into 32,400. Nothing I've done, I just took it into the numerator. Okay, now this is simple multiplication. I'm going to multiply from the right hand side. So what I'm going to multiply is, I'm multiplying 15 and 32,400. So I get delta L is equal to 11.5 into 10 raised to minus 6 into 4,86,000. This is what I have got. Now, normally what happens is, whenever you come across such a multiplication where there's a number like 10 raised to minus 6, we actually get a little nervous and we start getting confused. You don't have to do anything to that 10 raised to minus 6. Let the 10 raised to minus 6 remain as it is. Just multiply the remaining numbers. So, delta L, you have multiplied 11.5 into 4,86,000, and then you are keeping that 10 raised to minus 6 as it is. Okay, now what do you do to this? This 10 raised to minus 6, it is in the numerator. What do you have to do? You have to bring it in the denominator to simplify this. When you bring it in the denominator, the 10 raised to minus 6 becomes 10 raised to 6. That means a number which has 6 zeros in it. So this is how it will look. The number, let it be as it is in the numerator, that 10 raised to minus 6, you have taken it in the denominator and it has become positive. It was minus 6, it has become plus 6 now. Now you are simplifying it. I have got a number which has 6 zeros in it, which is in the denominator. My numerator also has zeros. So the zeros that are there, it will cancel out. 3 zeros in the numerator cancels the 3 zeros in the denominator. Now what do you get? After you cancel out, you get 5,589. However, this is a number that is getting divided by 1,000. Okay, so 5,589 divided by 1,000 is what you get. Because it is divided by 1,000, 1,000 has 3 zeros in it, and that is why you put a decimal in the numerator number 3 places from your right, because it is divided by 1,000 and 1,000 has 3 zeros. So your final answer will be 5.589. This can also be written as 5.6 centimeter. So the change in the length is 5.6 centimeter. Okay, I hope whatever was done today was clear. Okay, so whatever has been done now, whatever you all are doing in this 8th standard, it is new to you all, so it is very important that you all follow certain steps so that numericals become simple for you all. How are you supposed to do it? First of all, know your formulas very well. Okay, watch the video again. Whatever we have solved, I've solved 5 sums today. Watch the video again, practice these numericals. Practice these numericals again, and then try solving similar numericals or solved examples which are given in the textbook. Okay, I hope that whatever has been done today is clear to everyone. Okay, we will be solving more numericals, but it's important that what is being done today is clear to you all and you'll practice it properly so that whatever will be done in the next class becomes very more clear. Okay, thank you.